The primary spacecraft studying Jupiter is NASA's Juno spacecraft. The spacecraft gets its name from Greek and Roman mythology. In these myths, the god Jupiter veils himself in clouds to hide his mischief. Jupiter's wife, the goddess Juno, was able to peer through these clouds to see Jupiter's true self, just as the Juno spacecraft peers through Jupiter's clouds in hopes of understanding the planet's true nature. Launched in 2011, Juno began its 1.7 billion-mile journey to Jupiter and officially began orbiting the planet on July 5, 2016. Juno's mission is to probe through Jupiter's thick clouds and answer questions about Jupiter's origin and evolution, our solar system, and giant planets throughout the universe. What discoveries has Juno made that have forever changed our understanding of Jupiter and our solar system? Watch to the end of the video to find out. Join us as we look at what NASA's Juno found in space. One of Juno's key tasks is to probe through Jupiter's clouds to provide a better understanding of the structure of Jupiter's atmosphere below the clouds. Juno is accomplishing this by mapping variations in the atmosphere's temperature, composition, clouds, and movement patterns. Let's look at Juno's top discoveries. Watery Jupiter. In 1995, NASA's Galileo spacecraft, no longer in commission, dropped a probe into Jupiter's atmosphere and found there to be 10 times less water than scientists expected. Juno has confirmed that this is not the case, and most of the water in Jupiter's atmosphere is found near its equator, where water makes up about 0.25% of the molecules in Jupiter's atmosphere. First images of Jupiter's North Pole. Juno captured the first images of Jupiter's North Pole, revealing a field of blue storms. Jupiter's North Pole has 9 storms, one centrally located surrounded by the other 8. These storms are anywhere from 2,500 to 2,900 miles wide. Data from Juno has revealed that while the arms of these storms may collide, the storms do not merge. A new cyclone. Near Jupiter's south pole, there was a grouping of 6 massive cyclones in a seemingly fixed pattern. On a close flyby over Jupiter's south pole, Juno discovered that a new cyclone has joined this group. Each of these storms is about the size of the continental United States. Lightning. Multiple spacecraft, Voyagers 1 and 2, Galileo and Cassini, had detected lightning in Jupiter's clouds through measuring radio frequencies. They only detected lightning at lower radio frequencies, which is unlike the lightning we have on Earth. Juno orbits much closer to Jupiter than these past spacecrafts and has detected lightning at higher frequencies. Jupiter's magnetic field. Jupiter has an intense magnetic field that is believed to originate from metallic hydrogen at its core. Metallic hydrogen comes from hydrogen gas being squeezed into a fluid under great pressure. While it has been known that Jupiter has a strong magnetic field, Juno has revealed that it is more intense than expected. Jupiter's magnetic field is about 10 times stronger than Earth's magnetic field. High voltage poles. Jupiter's intense magnetic field creates the brightest auroras in our solar system. Auroras are the colourful displays of light in the sky that shine when charged particles from the sun interact with the planet's atmosphere. We have them on Earth too, where they are known as the Northern Lights or Aurora Borealis. On Jupiter, Juno samples these charged particles and the magnetic fields, all while observing the auroras. Due to Jupiter's size, these auroras are more extreme. High-voltage electrical charges contribute to the formation of auroras. Jupiter experiences energies up to 400,000 electron volts with its auroras. The most powerful auroras on Earth have only hit a few thousand electron volts. Great Red Spot. One of Jupiter's most identifiable features is the Great Red Spot. This giant spot is a massive storm that we have seen for centuries. However, we are now seeing this storm shrink. In 1979, we measured it to be twice the size of Earth, Now it is only approximately 1.3 times the size of Earth. Juno has explored the depth of this storm, revealing that it is 200 miles deep, 50 to 100 times deeper than the Earth's oceans. The giant blue spot. Juno made the first definitive detection of a planetary magnetic field that changes over time. This changing magnetic field is called secular variation. The secular variation is strongest in a region that is known as Jupiter's giant blue spot, an intense patch of magnetic field near Jupiter's equator. The Juno spacecraft. What allows Juno to make all these amazing discoveries? Juno has a six-sided cylindrical body with 3 solar panel blades extending outward. In a feat of engineering, Juno continuously spins to keep itself stable as it makes elliptical orbits around Jupiter. Some parts of this orbit take Juno far away from Jupiter and its moons. As it passes closer, within 3,100 miles of Jupiter, all of Juno's instruments can be put to use. These include microwave radiometer. Juno measures microwaves coming from deep within Jupiter's atmosphere with an array of 6 antennas. We use microwave measurements to determine what Jupiter's atmosphere is made of, as well as its temperature. Gravity science experiment. Juno communicates directly with NASA's Deep Space Network in Goldstone, California, as it orbits Jupiter and detects radio signals coming from the planet. Goldstone can measure subtle changes in the radio signals that occur from a shift in Juno's position as a result of variations in Jupiter's gravitational field. Mapping the variations in Jupiter's gravitational field can help reveal details of the interior structure of the planet. Magnetometer experiment. One of Juno's solar panel arms has a sensor that is responsible for building a 3D map of Jupiter's magnetic field. The shape of the magnetic field can reveal insights into Jupiter's dynamo, a mass of metallic hydrogen that is highly charged at Jupiter's core. Jovian Auroral Distributions Experiment, or JADE. JADE has 4 sensors targeting Jupiter's auroras, 3 that measure electrons and 1 that measures ions. Understanding the auroras can help scientists map Jupiter's magnetic field. Jupiter Energetic Particle Detector Instrument, or JEDI. JEDI measures high-energy particles crashing into Jupiter. Paired with JADE, JEDI can help scientists understand Jupiter's auroras and magnetic field. Jovian Infrared Auroral Mapper, or JIRM. JIRM's camera captures pictures in infrared light. This light can then be split into a spectrum to reveal the composition of gases in Jupiter's atmosphere. JIRM is also helping map Jupiter's auroras and produces images of the planet's atmosphere at infrared wavelengths. Waves. There are 2 wave sensors that track plasma waves and radio waves that pass through Jupiter's magnetic field. This will help scientists understand how Jupiter's magnetosphere and its atmosphere interact with each other. JunoCam. Finally, JunoCam takes pictures in the visible part of the light spectrum. Due to Juno's perpetual spin, it must take pictures in small strips that are later sewn together. JunoCam is what has been providing us with the amazing pictures we have of Jupiter and its moons. Mission timeline. Juno was launched on August 5th, 2011. It spent August and September of 2012 performing deep space maneuvers to then come back and get a gravity assist from Earth on a flyby in October 2013. Finally, in 2016, Juno arrived at Jupiter and successfully began to orbit the giant planet. Juno's first 35 orbits of Jupiter made up its primary mission. During this prime mission, Juno collected more than 3 terabits, equivalent to 375 gigabits, of scientific data, along with amazing photos of Jupiter and its moons. The primary mission concluded, and Juno's extended mission, an additional 42 orbits, began in August 2021. Juno will continue to orbit Jupiter until its mission completion in 2025, or until the spacecraft's end of life. During its extended mission, Juno will expand on its previous discoveries. A focus in the extended mission will be Jupiter's giant blue spot. Juno will remain in its extended mission phase until it is completed in September 2025 or until the spacecraft dies. 2022 Discovery. Juno has already captured the first close-up picture in over 20 years of Europa. Captured in September 2022, this is the highest resolution picture of a specific portion of Europa not previously imaged in such a way. It reveals a region with peculiar features that, with an understanding of how they formed, will reveal information about the internal and external processes that shaped the icy crust of the Moon. What's next for Juno? As Juno continues into the extended part of its mission, it will become an expert in the full Jovian system, Jupiter, its rings and its moons. There are multiple rendezvous planned for Jupiter's three most intriguing moons, Europa, Ganymede and Io. Multiple passes through Jupiter's rings are also planned. Tell us what you hope Juno finds on Jupiter in the comments below, and let us know if you have any suggestions or feedback for us. We appreciate your input. Thanks for watching, and take a moment to check out this next video, which you might find intriguing.